Good morning, students. So today we will be starting a new topic, uh, trees, which is Unit 3 in your uh, syllabus. So let us start our new topic. So first of all, we will see what is linear data structures and what are non-linear data structures. So a linear data structure traverses the data elements sequentially, in which only one data element can directly be reached. अभी तक आप लोग यूनिट 1 एंड यूनिट 2 में ऑलरेडी एरेज, स्टैक्स, क्यूज, लिंक्ड लिस्ट पढ़ चुके हैं. ऑल दीज आर द लीनियर डेटा स्ट्रक्चर, बिकॉज इन लीनियर डेटा स्ट्रक्चर हम लोग एक एलिमेंट से दूसरे एलिमेंट तक सीक्वेंशियल मैनर में पहुंचते हैं, राइट? Whereas in non-linear data structure, every data item is attached to several other data items in a way that is specific for reflecting relationships. The data items are not arranged in a sequential structure. Example, trees and graphs. So, like in arrays, हम लोग जो भी स्टोरेज कर रहे हैं वो लीनियर फैशन में कर रहे हैं, या स्टैक्स में, या क्यूज में, या लिंक लिस्ट में. So one element is connected to one element. Whereas in trees and graphs, one element can be connected to more than one elements, because it is a way of reflecting or showing the relationships among the different elements. So let us look with the example. So tree is a finite set of one or more nodes such that there is a specially designated node called root. The remaining nodes are partitioned into n greater than or equal to 0, where n is a number which should be greater than or equal to 0, disjoint sets, that is T1, T2, T3, T4 till Tn, which are called as subtrees of the root. So let us look at with the example. So this is our tree. Now the T1 node is the root of the tree, and from here I have connected several other nodes. So with T1 I have connected T2, T3, T4. So these are the subtrees of T1. Then T3 has again got another node connected with it, that is T5, and similarly T4 has got another node connected with it, that is T6 and T7. So now here see the definition. There is a specially designated node called a root. So here our T1 is a root. Now the remaining nodes are partitioned into n greater than or equal to 0 disjoint sets, T1, T2, T3, T4 till Tn, which are also called as subtrees of the root. So here our subtrees of T1 is T2, then T3 and T4. So these are disjoint sets, means no nodes will be common in these subtrees among themselves. So this is the formal definition of a tree. Now let us look at this example. So here T4 is connected to T6 and T7. So these T6 and T7 will be called as child nodes of this T4, and T4 is a parent of T6 and T7. Now again another example. This tree has got one node T1 as a root, and T2, T5, T6 and T7 will be called as leaves or terminal nodes. It means after these leaves or terminal nodes, no other node is connected. So the end node of any subtree is called as leaf or a terminal node. Now, degree of the node. Number of subtrees attached to any node is called the degree of that node. Like here in example, this T1 node is connected to 3 other nodes, T2, T3 and T4. So degree of T1 is 3. Similarly, T7 is connected to one node, that is T6. So degree of T7 is 1. Now degree of the tree will be the maximum degree of any node present in that tree. So here I have written, this is our tree. here I have written T1 के साइड में मैंने 2 लिखा हुआ है, then 3 behind this T2. All these are indicating the degrees of these particular nodes. So we can see that in this whole tree, the maximum degree is of T2 and which is 3. So my degree of a tree becomes 3. Now level of a tree. So the root node is at level 0 and subsequent nodes will be at level 1, 2, 3, etc. So here our T1 is our root node, which will be is at level 0. Then T2 and T3 are subtrees of T1. So these will be at level 1. Then again T2 has got T4, T5, T6 connected and T3 has got T7 connected. So T4, T5, T6 and T7 will be at level 2 and T8 and T9 will be at level 3. Now height of the tree or depth of the tree. So the maximum level is the height of the tree. So in above example, height of the tree is 4. 1, 2, 3 and 4. Now predecessor, while displaying the tree, if some particular node occurs previous to some other node, then that node is called the predecessor of the other node. So in this example, T2 is read first and after that I have read T4, then T2 is the predecessor of T4. Or we can say that T4 is the successor of T2. So successor is a node which occurs next to some node. Now internal and external nodes. So the leaf nodes are called external nodes and non-leaf nodes are called internal nodes. So here in this example, T1 is the root, T2, T5, T6 and T7 are the terminal nodes or the leaves, and T3 and T4 are my internal nodes. So non-leaf nodes are called as internal nodes. Now siblings and brothers, the nodes with common parent are called siblings. So in this example, here T4 has got 2 childs, T6 and T7. So T6 and T7 will be called as siblings or brothers because they have got common parent called T4. Now forest. Forest is a collection of disjoint trees. If we delete the root node of a tree, then we get the forest. For example, in the upper level, see, this is our tree with T1 as a root. And if we remove this T1, then whatever is left is known as forest. So forest is nothing but a collection of disjoint trees. So in independently, all these are trees, T2, T3 and T5, T4, T6, T7, all these are trees independently, and these are disjoint trees. So this collection of these disjoint trees is known as forest. Okay, so that is all for today. Thank you.